Good morning, everyone. Today we're going to start our Unit 7 review, which was topics all about trigonometry. So at the beginning, we talked about angle measurements and how to convert between degrees and radians. So we are going to do one of each. So when you have a degree measurement like this one, 225, and you want to change it to radian, so let me write this, degree to radian, you're going to multiply by pi over 180. Okay, so for this number, 225 times pi over 180. I mean, when you multiply across, you have to remember that this is technically over an invisible 1. So you would get a huge number, 225 pi over 180. So you want to simplify that as much as you possibly can. So the shortcut is you can type this into the calculator, just omit the pi, do not type in pi. But if you type in 225 over 180, the calculator will automatically simplify it for you, which it ends up being 5 over 4. And then you just got to add your pi symbol back in. So our final answer here would be 5 pi over 4. Okay, on the other hand, if you wanted to convert from radians to degrees, so on this side we're going radians to degrees, you're going to multiply by the opposite. So this time it's going to be 180 over pi. Okay, so let's do this. 3 pi over 5 times 180 over pi. Automatically, you should hopefully see that since there's a pi on the top and the bottom, we can cancel that out. Then you can just multiply like normal. 3 times 180 is 540. And then at the bottom, I still have my 5. So we can simplify that even more. And that ends up being 108. So 108 degrees. Okay, so that is our degree and radian conversions. The next thing that we talked about was coterminal angles. So coterminal, I mean, when you think of the word terminal, you should think about things that are ending. So if they're coterminal, that means that they end at the same spot. So they want us to find two coterminal angles for each one positive and one negative. So think about a circle, our unit circle, right? 315 would be, so here's my quadrants. 315 would be somewhere over here, not exact, but we want to find a positive angle that would also land on the same spot. So basically, starting from the 315, if I went all the way around and landed on that same line, what number would that be? So you have to remember that a full rotation, when it comes to degrees, is 360. So the way you can figure out some coterminal angles here is you take your angle, so we're going to use the symbol theta, and either you can add or you can subtract 360 degrees. So that's what we're going to do here. 315 minus 360 gives us negative 45. So if I were to graph negative 45, that would land at the same spot as 315. Okay, now we want to find a positive one, so this time let's add 315 plus 360 gives us 675. Okay, so that angle would also land right on top of our 315. So the trick here is just that 360 is a full rotation. Okay, for this one here, it's the same idea. It's just that when you're in radians, a full rotation is 2 pi. So you're going to start with your angle, theta, and either you're going to add or subtract 2 pi. So let's start with subtracting. 11 pi over 6 minus, by the way, since we are using 6 here, 2 pi. If I wanted it to have a denominator of 6, I would have to write it as 12 pi over 6, because 12 over 2 will 12 over 6 simplifies to 2. And when we're subtracting, we need to have that common denominator. Okay, so this makes it easier. 11 minus 12 is -1, so this would just equal negative pi over 6. Okay, and then on the other hand, let's add plus 12 pi over 6. 11 plus 12 gives us 23. And then just always make sure you cannot simplify that, but we can't. 23 over 6 has to stay. So there is our positive angle. Okay, next thing we talked about was arc length and sector area. So we're going to actually do both for both of these circles because we need to practice using degrees and then we need to practice using radians. So for this circle, we're going to find the arc length and sector area of the shaded region. So when I talk about arc length, it's kind of like circumference, only we're not going to go all the way around. We're only going to go on that shaded region. So it looks like a little bit more than half of the circumference. So the formula for arc length, and we use the letter S, by the way, so arc length, it's a little s, is equal to r times theta. But it's important that your theta is in radians. So that means that we're going to have to convert that angle to radians within the formula. So you could do it separately, but I like to do it within the formula. Okay, so arc length S is radius. So our radius is 11.2 times our angle. So our angle is 205, but I need that to be in radians. So if you remember from above, when I have degrees and I want to change it to radians, I need to multiply by pi over 180. So I'm just going to build that into my equation here. So multiply by pi over 180. So this is not going to be an exact number. This is more of an approximation. So you can go ahead and just type it all into the calculator all at once. And when we do that, I get 40.1, and they are measuring in feet. Okay, now let's also look for sector area. So again, it's like area of a circle, only we're not finding the entire area. We're only looking at the shaded in region, so a little bit more than half the circle. So sector area we use a capital A. The formula for that is 1/2 radius squared times theta. Again, that angle, it needs to be in radians, so we're going to have to throw in our conversion factor here. Okay, so 1/2. Our radius is 11.2, but we want to square that. And then times our angle, 205. But in order to make sure it's in radians, we're also going to multiply by pi over 180. So again, all at once into the calculator. And when I type this in, I get 224.4. We're measuring in feet, so this would be square feet. Okay, so that is arc length and sector area of this circle. where it measured the angle in degrees. Okay, so the next one, it's still the same thing, only here, when they measured the angle, they have it in radians. So that's our theta, and 7 is our radius. So for sector area, same formula as from before. Area equals 1/2 radius squared times theta, where the angle has to be in radians. It's actually easier when it's already in radians because I don't have to do any conversions. I could just plug in everything. 1/2 7 squared times 2 pi over 3. All into the calculator all at once, and I get 51.3. This time they're measuring in kilometers, so kilometers squared. Sorry, I don't know why this time I decided to go backwards. I did sector area first. Now let's go back and find the arc length. So arc length would be the length of that piece right there. Arc length. So little s equals radius times theta, where the angle is already in radians. So this is pretty straightforward. 7 times 2 pi over 3. So when I type this in, I get 14.7, and we're measuring in kilometers. Okay, so I wrote the equation a bunch of times. So arc length, sector area, arc length, sector area. So just follow the equation here. This one shouldn't be too difficult of a problem. Okay, so here's where it starts to turn into a little bit more work. It says solve each right triangle, round your answers to the nearest tenth. So when they ask you to solve the entire triangle, what they want you to do is find everything that's missing. There's 3 sides and there's 3 angles, so you need to have numbers for each one of them. There's a bunch of things that you can do. The main thing, since this is the trig unit, is to use TOA. So that stands for our 3 trig ratios, sine, cosine, and tangent. So that's one thing you can use. Another thing that you can use is the Pythagorean theorem. So if you already have 2 of the sides and you only need 1 more, that's another option. And then lastly, the interior angles of a triangle are equal to 180. So all 3 of those things are going to help us solve this triangle. So here, let's take a look at what we're missing. We are missing angle D, angle F, and then this side here at the bottom. So let's just do one at a time. So let's start off by looking at angle D. Okay, so when I look at angle D, I'm going to label the sides of this shape. This is our hypotenuse at the bottom, because that is across from the right angle. Here's angle D. When I go across, that would be opposite, which leaves this as adjacent. Now, hypotenuse is blank right now, so I cannot use that. I have to use one of the trig ratios that uses opposite and adjacent. So I'm going to scoot over really quickly. That would be here, tangent. O and A stand for opposite and adjacent. Okay, so because this is angle D, let's say tan of capital D is equal to 22.5 over 21. Now, I want D to be by itself, so when I divide by tangent, it becomes an inverse. So I have tan inverse of 22.5 over 21, and that is what you're going to type into your calculator. Now, make sure, I probably should have said this at the beginning, that your calculator is in degree mode, because We want to get the measurements of these angles in degrees. Okay, so now let me type that in, and I get that angle D is 47 degrees. Okay, now I know that that angle is 47. I'm going to use that trick from over here, that all triangles are 180. So I know two of those angles. E is 90 because of the right angle. D is 47. So if I wanted to find angle F, I would do 180 minus the two that we have. And I get 43. So angle F is 43 degrees. Okay, so now I have both angles. So what else am I missing? The hypotenuse. So now you can use trig for this for sure, but we could also use the Pythagorean theorem. So I'm going to use that one. Pythagorean theorem, a squared plus b squared equals c squared. Just make sure that c is always your hypotenuse. So we would have 21 squared plus 22.5 squared equals, I'm going to leave it as c since we don't know what it is yet. So if I type in just this left part, I'm getting 947.25, but that still equals c squared. I need it to be just regular c. So we're going to square root both of the sides, and now I get, and we're rounding to the nearest tenth, that is 30.8. Okay, so now we have values for everything. We have values for all three angles, and we have values for all three sides. This one right here was 30.8. Okay, so let's do another one like that. So here's our new figure. And we're going to find everything that's missing. So first off, I would do angle R. Because I already have two of these angles, remember that square means 90. So for angle R, I would do 180 minus the 90 and 34 that we have already. So angle R is 56 degrees. By the way, it's kind of a coincidence that it's a whole number. It's said to round to the nearest tenth, and it just is rounding this way. Okay, so now let's find the missing two sides. Since there's two missing sides, I'm just going to label them two random letters. So say this is A and this is B. We need to find the length of those two sides. So I'm going to start with A. So 42 is our hypotenuse because it is across from the right angle. And if I start by solving for A, here's my 34. When I go across, that makes A opposite. And B is the last one left over, so adjacent. So if I'm starting with A is opposite. And I have a number for hypotenuse, so I want to use the trig function that uses opposite and hypotenuse. So if you remember so, ka, toa, that is sine. That's so. So sine of 34 degrees. So I'm using this angle here is little a over 42. Okay, so we're going to move that 42 over to the other side. That way the A can be by itself, which gives me this. And that is what you're going to type into your calculator. When I type it in, I am getting and we're rounding to the nearest tenth, 23.5. Okay, now let's solve for little b. Little b is adjacent. And I'm going to keep using hypotenuse just because that one already has a number. So adjacent and hypotenuse, that would be cosine. So cosine of 34 is little b over 42. So this is really similar to the one that we just finished doing. Type that into your calculator, round to the nearest tenth, and I am getting 34.8. Okay, next one. So this is a triangle. All the triangles have positive angles, and they're always going to be acute, but not all angles are positive and acute. There's negative angles, there's obtuse angles. So this next question is finding the exact values of any angle. So what they're going to do is they're going to give you a point. So point B, which is -6, -2, is a point on the terminal side of theta in standard form. Find the exact values of the trigonometric functions of theta. Okay, so I'm going to draw us a picture here. There's our coordinate plane. It doesn't have to be super exact. -6, -2 means that has to be in quadrant 3. That would be somewhere down here. So our angle that they're talking about is something that's going exactly through that point. So that's point B. So you have to create a triangle here. There's our right angle. And just because of the way that, X and Y axis works, this is my X axis. My X value is -6. So this length has to be -6. This is my Y axis going up and down. Y value is -2. So the length of that piece is -2. So we still have to find out what the hypotenuse is of that little triangle that we created there. This, space here. So we're going to use a Pythagorean theorem. -2 squared plus -6 squared is equal to, here we call this the radius, so I'm going to call it r squared. So that left side, if you type it all in, gives us 40. Now I'm going to square root both sides, so it would be square root of 40. Only you can simplify that a little bit. If you remember doing these factor trees like this. So this, we can reduce it down to 2 square root of 10. So that is what we're going to use for r. 2 square root of 10. Okay. So we officially have that x is -6, y is -2, and r is 2 square root of 10. I'm just getting this from the point, that's x and y, and then this r is what we just found. So the reason why I'm writing them out is because it makes things easier. Sine of theta is actually equal to y over r. So we're going to do -2 over 2 square root 10. So we have a few problems we can simplify. So the 2's can cancel each other out, but then I'm not allowed to have a square root at the bottom, so we're going to rationalize by multiplying by that square root. So that turns this into negative square root 10 over regular 10, because here, this would be square root of 100, which we know is 10. Okay, let's do cosine. So cosine theta is x over r. So we would do negative 6 over 2 square root 10. So same thing, we need to simplify and rationalize. 6 over 2 would simplify to just 3, but then we need to multiply by square root of 10 top and bottom. So we get negative 3 square root of 10 over regular 10. Okay, tangent is y over x. So we would have negative 2 over negative 6, but that will simplify into a positive 1/3. Okay, so those are the main three, but I also want to do the other 6. So that means that we need to do cosecant, secant, and cotangent. The good thing is that it's the reciprocal, so it's a lot faster. So I'm going to take this first one, and if I were to flip it over, those two still cancel out. So it's going to leave me with negative square root of 10. So that's cosecant. For secant, same thing. I'm going to take my original, flip it over, and this gets me negative square root of 10 over 3. And then for cotangent, 1/3 when you flip it over is just 3. Okay, so those are all the trig values for that angle that's formed by the terminal side being on point B. Okay, this review is getting kind of long, so I'm going to stop it right here, and I'll make a second video for the second half of the review.